Happy Monday, fifth graders. Hope you guys had a good weekend. And let's get started with our science. Today we're going to take a look at mixtures and solutions. Now, last Monday we talked about mixtures. So today I'm going to add the solutions because they kind of work as a team. Review time. Let's review mixtures. A mixture is two or more types of atoms that are not chemically combined together. Remember, if they're not chemically combined, they have a physical change. If they change what they are, become something new, they become a chemical change. So we're still looking at a physical change. A mixture can be two solids, it can be two or more liquids, it can be two or more gases, or it can be a combination of solid and gas, liquid and solid, gas and liquid, etc. So that is a mixture. Those atoms are not chemically combined. They simply can be changed. They're not chemically combined. So let's look at some of these combinations. We have a mixture of coins. We have nickels, dimes, pennies, quarters. There's a mixture of solids. We have a mixture, looks like some type of ravioli. Those are mixtures of colors. We have a mixture of the orange and the mixture of the white. We have a mixture of the red and a mixture of this tan and this spice. So these are all solids. These are mixtures. These are physical mixtures. Then we also have a mixture of liquids. We have the coffee. We have a mixture of orange juice. It could be grape juice. It could be lemon juice. It could be cranberry juice. Those are mixtures of a liquid. We have these mixtures in these cylinders. Now, these could also be changed. These are, in middle school, you're going to be doing some science. And you guys could be using beakers. So you have these different liquids in the beakers. We can mix them up together. So these are mixtures of liquids. We tend to forget about gas. Gas is also a mixture. We have different helium, we have oxygen. So we know that we can have a mixture of gases. Now, we also talked about heterogeneous and homogeneous last week. So let's review that. Remember, a heterogeneous means different. You can see the different parts of the mixture very easily. You can see those phases easily. You can easily separate the ravioli pieces. You can easily separate different types of rocks. You can easily separate different types of candy. That would be a heterogeneous mixture. But then we have a homogeneous mixture, which means the same. You can't see the different parts of the mixture, but we know that they're still there. So if we had any kind of liquids that are mixed together, you can't see the coffee grinds and they go into the water. They create coffee or they create tea. You can't see the different liquids, but they're there. So that would be a homogeneous mixture. So an example of a heterogeneous mixture, we have the different color leaves. They're all leaves, but they're different colors. We have the soup. We have the noodles. We have like meatballs. We could separate the meat from the noodles, from the peas. Then we have the coins. We could easily separate the quarters from the dimes, from the nickels, etc. So this would be a heterogeneous. All of these atoms are different. That would be a heterogeneous mixture. Homogeneous mixture means they will be the same. So we have the atoms in this balloon, in this liquid cup, in this coffee. All of these atoms are the same. You cannot see the different phases of that mixture, but we know that they're there. So in your brains, put in your thinking caps. I want you to figure out which one of these types of mixtures. I need you to classify them. So the first one is our cereal. So put in your mind, is it a heterogeneous mixture or is it a homogeneous mixture? I'm going to give you some think time. If you said the answer is heterogeneous, you would be absolutely correct. We have the different colors of the cereal. We could separate those easily. Now let's try grape juice. Put in your minds, put your thinking caps on. Is that heterogeneous or is that homogeneous? If you said homogeneous, you would absolutely be correct. All of those atoms are the same in your grape juice. Now, our last one would be these Easter candy colored eggs. Would that be a heterogeneous mixture or a homogeneous mixture? Your answer is heterogeneous mixture. So remember, heterogeneous and homogeneous are the two types of mixtures. Anytime you hear the word heterogeneous, that means those things are different. Anytime you hear a thing of a homogeneous mixture or anything that's homogeneous, it means the same. So now let's talk about a solution. The solution is a teammate to mixture. A solution is simply a special type of mixture. A solution is a homogeneous, remember, homogeneous means same, that combines a solute and a solvent. Now, you already know what a solute and a solvent. Tell your brain, remind yourself, tell your puppy, your kitten, whoever happens to be beside you, what is the universal solvent? You should tell them it is water. Why is water the universal solvent? Because we know that water is pure. You will have to put something in it to change what it is. So water is your universal solvent. So a solution involves a substance dissolving another substance, which is usually a liquid. So in fifth grade science terms, a solution is your solute that you mixing in your solid to dissolve. And once it dissolves, you have your solution. Remember when we had our salt solution? Your salt was your what? Correct. Your salt was your solute. What did we try to dissolve that solute in? We dissolved that solute in our solvent, which was our water. And what did we make? You so smart. We made a saltwater solution. So remember, this should be a review. We've already discussed the solutes and the solvents. So a solution, we said, is a special type of mixture. Here we have our solute. It looks like sugar crystals. We're going to take that solute and we're going to put it in our universal solvent, which is water. Now, fifth grade, keep in mind your solvent will not always be water, but your solvent most of the time will be a liquid because you're going to use your liquid to dissolve your solute. But in this case, our solvent is our water. So the solid is the part that's getting dissolved, for example, salt or sugar. The liquid, in this case, is the water, is doing the dissolving. And that creates a what? Correct. That creates a solution. A solution is homogeneous. So we take our salt crystal or our sugar crystal and we put it in our solvent. And what again do we create? Ding, 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 ding. Solution. So how to make a solution? Take a solute and a solvent, mix it all together, and get a solution. Y'all, it's not that difficult. That is a solution. Now, we can measure how easily a solute would dissolve in a certain solvent, and that measurement is called the solubility. It's either have a high solubility or it's going to have a low solubility. If it dissolves quickly and easily, like we did with our salt water, when we had the egg in the salt water, that would be high solubility. But if it does not dissolve easily, like if you put sand with water, it's not going to dissolve very quickly. And looking at this container or this beaker, which one has more density, the water or the sand? I think I heard you say the sand, and you're absolutely correct. How do you know the sand has more density? Correct. The sand is at the bottom. So you see where the sand and the water, we know it's a mixture because we can pour the water off and we have the sand at the bottom, but it's low solubility, meaning it does not dissolve very easily. So that would be an example of low solubility. Now we have something that's diluted versus something that's concentrated. We can either add a little solute or we can add a lot of solute. So for example, when we put spoonfuls of sugar in a cup of tea, a solution with only a small amount of solute means it has diluted. So if I take my solution, and this before it got diluted, and I added water, what does the molecules do? Correct. They start to move around. That's going to help it to dilute. So here we have two beakers. They contain the same amount of molecules from the solute. One is that one has been diluted and the other has not been diluted. So diluted, remember when we made the salt water with the egg in it. I kept telling you, we kept stirring, and I said I would show you guys once everything dissolves in. So this is what I was trying to show you with the egg, how the molecules are going to change based on how much you stir it to get it either concentrated or to get it diluted. So this is what those molecules look like before you dilute it and after you dilute it. So this would be our egg cup after I stirred it and all the salt and the water began to combine together. So a large amount of solute would be concentrated. Now let's go back to our egg example. Our egg example, would that be a little solute? Would that be, I'm sorry, would that be a dilute or would that be a concentrated? That would be a concentrated. Because remember, I put a lot of salt in that water and oversaturated that water. So that would have been a concentrated amount of salt that was put in that egg water. So that would be concentrated. Now, a lot of you guys like your Kool-Aid, and you put a pack of Kool-Aid in a container, and you will put the Kool-Aid packet in, and then you pour 5,000 gallons of sugar in it. Oh my goodness, the dentists love y'all. So therefore, you have made a concentrated Kool-Aid solution. A saturated means you put so much in it, it cannot hold any more solute at a certain temperature. So if I take something, take a solute, and I put it in, and I pour it in, and I pour it in, and I pour it in. Eventually, that solvent can't hold anymore. So when that solvent can't hold anymore, it looks like this. These showing the atoms, and they've been added and added. Eventually, it can't take anymore. So that would be a saturated solution. But we can keep going. If you add heat to add the solvent up, it'll help those molecules, because what does heat molecules do? How do they move? Correct. They move very quickly, and they're going to move around so that you'll be able to add more solute to it. So if you want to supersaturate, and we talked about saturate, now it's supersaturated. If you want to supersaturate it, it's going to hold more than it would normally dissolve. So, but in order to supersaturate it, you would have to do what to it again? Correct. You're going to have to heat it up. And when you heat it up, those atoms or those molecules are going to move around. And as it's moving around, it's going to allow more solutes to enter in it. So the supersaturated, we have example A, and you see we're getting more the more the solute. We've added more the more the solute. And then to get it to hold any more, you would have to heat it to get more the more the solute. This is called super saturated solution. So an unsaturated solution would be an example of this one. We're pouring in the sugar cubes. And sugar cubes are your what? That is your solute. We're pouring it into our water, which is our what? It is our solvent. So we take this solute, we pour it in our solvent, more is going to dissolve, and that will be your saturated. Now, we've gotten to a point now, it will not hold anymore. This solvent will not hold anymore. But what can I do to get it supersaturated? I can heat it. When I heat it, I can create more crystals. And unfortunately, we're not going to be in school to be able to grow crystals because I have a crystal kit. But unfortunately, next year's class will be able to do it. But you have supersaturated crystals because we have a supersaturated solution. Now, you know I'm always taking things back to the real world. What is an example of something in the real world that's super saturated with sugar? Hmm. Did you think about candy? Candy is super saturated. It has a lot of sugar in it. So, candy is a real world example of super saturated. So, I want you to go to Edpuzzle and look at this video, solution, solvent, solute, definition, and difference. So it will give you an animation. You know I'm all about the visuals. It will give you more visuals about solution, solvent, and solute. After you finish the video, I need you to pause this one, go to Edpuzzle, come back to this video, and we'll continue. Okay, so I hope you enjoyed that video and it helped give you more clarity on solution solvent. Now, go to Clever. From Clever, go to Discovery Education. Click on the Engage tab. You're going to have two assignments. You're going to do your Engage tab and you have an assessment. Okay, so I need you to go to Discovery Education, do your Engage tab. In your Engage tab, you have a video. And read your text to give you more information. Because fifth grade, y'all got to get ready for middle school. You have a video segment here, a video segment here, and a video segment here. Here you have questions. Where did it go? Answer the question, click submit. Here we have objects, diagram. You're going to click on the object to figure out what particles of salt are in the salt water solution. Then you're going to, it says a solution is one kind of mixture. The phases show different kinds of mixtures. Select all. When it tells you to select all, that means you're going to have more than one answer. So select everything that's going to describe a solution and click submit. And then can you explain it? Describe and explain what happens to salt when it forms a mixture with water. Now, y'all, we did this in class. I gave you an example of this in class, so you have a visual of this. So record your ideas here and click submit. Then you need to go back at the top of your page. Now your page won't look like mine, but up here it says assignments. You have two assignments. You have an assessment and you have your engage. You're not doing these tabs here unless you just want to, but the only thing I'm looking for is just the engage, and then you have an assessment. Make sure you click submit. Submit is the same as putting your name on your paper, okay?